The next section we're going to be looking at is a section on fractions. Now, fractions are very scary for a lot of people. They don't like them. But if you remember that all a fraction is just a combination of the quotient of two whole numbers, makes it a little more simple. So hopefully we'll be able to simplify this for you so that fractions won't scare you that much anymore. Fractions are separated into numbers that are called factors a lot of times. A factor is a number that divides evenly into another number. For example, if we were to look for the factors of 12, what you always do is start with the number 2. The reason why you don't start with 1, because 1 divides evenly into every number, and it really doesn't do us much, because we know from the identity property that anything times 1 is going to be itself again. So we start with 2. And then from there, if 2 we divide it as many times as 2 will go in, and then from there you go to 3, and so forth. I'll show you a factoring tree. 2 divides evenly into 12 6 times. Then 2 divides into 6 3 times. 2 doesn't divide into 3, so we go to the next number, 3. Here we have, this is called complete factorization, is what you call it, of the number 12. 2 times 2 times 3. Now we already learned a shorter way to write that with exponents. 2 squared times 3. That is the factors. If somebody were to ask you, write the factors of 12, 2 times 2, or 2 squared times 3 are the factors of 12. This number right here is called a composite number. Just like it sounds, it's composed of other numbers. The alternative to that is what's called a prime number. The definition of a prime number, like 7 is a prime number. The definition of that is it's only divisible evenly by itself and 1. Now we already talked about that 1 is a factor of every single number. So we don't list it. It's understood. So the factors of 7 are 7. That's it. You have other prime numbers, 3, 5, 7, 11, 13, 17, so forth. Those numbers are only divisible by itself and 1. In factoring, you always want to end up reducing a number until you have prime numbers. 2 is a prime number, 3 is a prime number, then you can stop. So when you're factoring, if you still have a composite number, you need to factor it some more. For example, 15. 15 is not prime. It does have numbers that divide evenly into it. 2 does not. We always start at 2. It's not an even number. 2 will not. 3 goes in how many times? 5 times. 5 also is a prime number. This is the complete factorization of 15. Now, we have 3 different classifications of fractions. The reason why we do factors is to kind of introduce us what we need for fractions. 3 types of fractions that we will look at are proper, improper, and mixed. Call it a mixed number. A proper fraction is a fraction that's been completely reduced down to the lowest terms. For example, 1/3. 1/3 is a proper fraction. 5/8. 5/8 is a proper fraction. 2/4 is not reduced to its lowest terms. You're supposed to always reduce whenever you possibly can. We know that 2/4 can reduce to 1/2. Also, more commonly looked at as improper is when the numerator is bigger than the denominator. Numerator over the denominator, always. So we have here 7 over 3. Numerator is larger. That's called an improper fraction. Last one we have here is called a mixed number. That's whenever you have a whole number and a fraction together. And it could be any type of different mixed numbers. 3 classifications of fractions. Now, how you express an improper fraction into a mixed number, 37 over 2 is an improper fraction. If I express that as a mixed number, I divide 2 into 37. Well, 2 will go into 36 evenly 18 times with a remainder of 1. So I have 18 and 1/2. 2 divided into 37 equals 18 over 1/2. Now, if the division is troublesome for you, go back to the division section and review that again. Another thing they're going to have to be doing with fractions is telling a very common problem or a question that you'll see in your classes is which is greater? (7 over 12) or 9 over 13? Now there's a number of ways we can do this, but the easiest way we're going to look at to do it is to first of all convert these into a fraction that has the same exact denominator. Well, if you recall from my list of prime numbers, 13 is a prime number, so the only factors it has are 1 in itself. So the lowest LCM for a 12 and 13 is actually their product. What happens to be 156. 12 goes into 156 13 times. 13 times 7 is 91. 13 goes into 156 12 times. 12 times 9 is 108. Now we have what are called similar fractions. They have the same exact denominator. So if you were to think about it in terms of a pie, there's 156 pieces this thing is divided into. 91 of them are gone in this particular fraction. Over here, same exact pie, but cut in the same number of pieces, but 108 of them are gone. Which one is more gone from? Well, this one right here. That means that fraction is the larger of the two. There's another concept that you need to do with fractions, and that is what's called finding the equivalent fraction. Meaning, find another fraction which is equal to the same thing. Is equal to it, but using different numbers. For example, 1/3. An equivalent fraction of 1/3 would be 4 over 12. All you have to do to find an equivalent fraction is multiply the numerator and denominator by the same exact number. In this particular case, what number times 1 is equal to 4? Well, of course 4 is. 3 times 4 is also 12. 4 over 12 is equal to 1/3. If we were to use 6, 6 times 1 is 6, 6 times 3 is 18. All of these are what are called equivalent fractions. They all equal the same exact thing. 2/5. Find the equivalent fraction of that. Let's use the number 3. 3 times 2, 6. 3 times 5, 15. Equivalent fractions and so forth. I think you understand how that works. In order to add and subtract fractions, you have to have what's called the least common denominator. The least common denominator is finding a number that they have in common. Now the numerator doesn't matter what it is, but you're going to be adding those. In order to add and subtract fractions, you have to have a least common denominator. What we then do is look for the smallest number that both of these numbers multiply into. 2 times 3 is 6. That's our least common denominator. The reason why we did this, find equivalent fractions, is to help us over here. What fraction is equivalent to 1/2 with the denominator of 6? 3 over 6. Over here we have a denominator of 6. What fraction is equivalent to 2/3 with the denominator of 6? Well, 3 goes into 6 2 times. 2 times 2 is 4. 4 over 6 and 2 over 3 are equivalent. They're the same exact thing. Now all we've done is write this. This is the same exact problem, but rewrote it so that we can actually add them together. Once you have a common denominator, write that down for your answer. You don't touch it. This allows us to be able to add or subtract. Now we add the numerators. 3 plus 4 is 7. And there's your improper fraction. If we were to convert it into a mixed number, it'd be 1 and 1/6, because 6 goes into 7 one time with a remainder of 1, 1 over 6. A very common mistake, now this is going to be wrong, a very common mistake that students will make in adding and subtracting fractions is say 3 plus 4 is equal to 7 for the numerator, which is right, but then they'll also add the denominators and say 6 plus 6 is 12. Completely wrong. Do not add the denominators. Never, ever, ever. Add or subtract. Let's try a problem like that with subtraction. 6 over 7 minus 3 over 5. Once again, we need to find our least common denominator. This particular case will be the product of 7 and 5. Both these numbers are prime. Their LCM will be their product. 7 goes into 35 5 times. I take that 5, multiply it by my numerator to find my equivalent fraction. There it is, 30 over 35. Likewise, 5 goes into 35 7 times. 7 times 3, 21. Equivalent fraction here and here. Now, because I have a common denominator, I can combine these two fractions. Remember, first write down what your fraction is, or your denominator, excuse me, and then this allows you to subtract the numerator. 30 minus 21 is 9 over 35. The last thing you have to check is to make sure that this right here is completely reduced. Are there any factors of 9 that divide evenly into 35? And the answer would be no. 3 is the only factor of 9, and 3 does not divide evenly into 35. If you're there, that's a proper fraction. You leave, that you got your answer. Very good. The last two operations we want to do with fractions are multiplying and dividing. These are a little easier. You may think it would seem more difficult, but actually the hardest operation with fractions is adding and subtracting them, because you have to find the least common denominator. With multiplying and dividing, you don't have to find one at all. So if I have 2/3 times 5 over 8, or 5/8, all I do is multiply 5 times 2, 10, and 3 times 8, 24. From there, I have to always check with fractions, always check to see if I can reduce. In this particular case, I can. 2 divides evenly into both, and I have an equivalent fraction of 5 over 12. So the product of 2/3 and 5/8 is actually 5/12. Let's do another one. Let's use 5/9 this time. 5/9 times 1/2. They want you to find 1/2 of 5/9. 5 times 1, numerator times numerator. 9 times 2, denominator times denominator. And then check to see if there are any common factors. The answer would be no. There's your answer. So the product of fractions, pretty straightforward. Multiply the numerators together, multiply the denominators, and then reduce whenever necessary. Find the quotient, or dividing them, is very similar, except for one extra step. And that is, let's use our first two numbers. 2/3 divided by 5/8. What you do is it's called invert and multiply. And you always invert the number on the right. Very, very important. So we're going to rewrite my fraction. Invert this one. Invert means, notice how I take it and I just flip it over to 8/5. So I invert and then I multiply. Well, we already learned how to multiply fractions. 2 times 8, 16. 3 times 5, 15. From there, make sure you don't have an improper fraction. Write it as a mixed number, 1 and 1/15. So the operation of division with fractions, if you remember this one little trick, invert and multiply, you'll never get the answer wrong. And always invert and multiply the second number, the number that is divided into the other one. Now, if you're having trouble with this concept, pause the tape and put in some numbers of your own so that you can rehearse this, because this is very, very important, these operations with fractions. I want to do a couple word problems using these fractions to see how it is that you can help here. I'm going to read you the problem first, and then we're going to break it down. Here's the problem. Your dental insurance reimbursed you $200 on a dental bill of $700. Did you get less or more than 1/3 of your money back? Now, word problems are typically very difficult for people. And the reason is they don't know the clue words that I told you before, and also they pay attention to details that don't really matter. So, here's what I'll tell you are the important things. You got back $200. Your bill was $700. They want to know, was it 1/3? Did you get 1/3 of your money back? Well, how you would find that, a couple different ways, but what we're going to do is using a fraction to say, okay, is 200, how does that relate to 1/3? Well, as you can see here, 200 over 700 is an equivalent fraction to 2 over 7. You can reduce that by dividing by 100. And you say, okay, how does that relate to 1/3? We did one of these earlier. We're going to find the least common denominator between these two, which will be 21. 7 goes in the 21 3 times, times 2. 3 goes in the 21 7 times. So an equivalent fraction of 1/3 is 7 over 21. An equivalent fraction of 2 over 7 is 6 over 21. Which one is larger? Our alligator mouth goes toward, or our greater than symbol goes toward the 7 over 21, which means that what we got back was less than 1/3. Let's look at the question again. At the very end they ask, did you get less or more than 1/3 of your money back? We got less than. So your answer would be less than.